I have started all services, Hadoop services, you can say. Hadoop means Yarn services as well, my mission, and also I'm in PySpark. Okay, this is Spark session is already there, and Spark context is also there. So we are in a PySpark shell. I just open my VMware. See, this is my VMware. Um, you know, and when we open in a browser, then it will come like this. Okay, like this. So for processing and verifying the data, I just opened two shells. Okay, so I already discussed this in our last session, but for whoever is joining today, so to have some idea, I just recap it, right? So quickly go to the topic. Today is very important topic that you generally know the difference between partition and coalesce, right? So, and if you don't know, please try to listen, because this is a very important topic, and we have to prove ourselves as a practical what exactly the repartition and what exactly the coalesce. Okay, before that, what exactly the partition, right? So partition is a very important topic in Spark, because to parallelize, okay, to parallelize existing task, then partition will make a more impact, right? So because of partitions only, we can able to a Spark can able to parallelize the executions, right? Then we'll get a output as early as possible as compared to other systems, right? So when I give you a small introduction about the what exactly the partition, and in a partition, uh, you know partition is a different, and partition by is a different. Okay, different means those are the, try to understand, partition is a concept of, like, if you see here in the screenshot, we have a big file. Okay, b1 is a big file, let us say 400 MB file, and a1 is a small file. Okay, and if you see application 1 and application 2, okay, so application 1 submitted by one user, and application 2 submitted by another user. Okay, so in just leave it about application 2 as of now, just concentrate on application 1. What exactly will happen when we submit any Spark application on a cluster, right? So let us assume we written some code. Okay, this guy, number one guy, has written some code, and he is referring one file which is there in a cluster, okay, or in a Hadoop, we can say, right? The file name is b1. Okay, b1 is how much the data it is. It is a 400 MB data size is there. Now he want to apply his logic and get output, okay, from this b1 file, correct? So this we can directly without partition can able to process it. But if you see, if we are going to send one file without this partition file to the cluster, if you see here, let us say we have 4 executors. Okay, so each executor may execute multiple tasks, right, based on the resources availability or container availability, right? If you are not clear this subject, please go to my session 2 or our previous sessions under the same playlist. You will understand what exactly is the executor and what is the virtual machine, okay, and what are the tasks. Okay, so all I have explained in detail in my app, right? So let us assume if we are sending a big file to the executor, okay, it may execute entire that file and give you output, but it will take a lot of time. Let us say when you submit this 400 file at a time to the cluster, then cluster definitely if just assume we don't have any partition concept. All right, so what will happen in a traditional system when we send this b1 file to the cluster, then let us assume it went to this executor. Okay, this executor, since only one file is there, it's supposed to execute entire file here only, correct? So obviously let us assume it took 4 minutes time to complete the process. Okay, but what happens, we need output in a less time. Let us assume here we divided into 4 partitions. Okay, 4 partition, this is a custom bifurcation. Okay, so if you don't mention anything, Spark, if it is a backend Hadoop, then 128 is a split size. All right, the partition size, in other words. But let's assume I divided intentionally 4 parts. That means each part approximately for 100 MB. Okay, it need not be the same, but approximately 100 MB. Okay, let us assume these 4 parts are sent to B12, B13, B14. Okay, now since we divided this data into 4 partitions, now each partition and each code will be executed on each partition. Let us assume it took only 1 minute time to process it. That means all 4 are processing in parallel, right? At a time, right? So in a minute, we are able to get output from 4 files, right? So we are saving here 3 minutes time. So let's assume if it is a 400 GB. If it is a 400 GB, then our files may be more, right? Based on the input split size or number of partitions, right? So this is more useful. This concept is more useful for a big data sets, not a small. Okay, small anyway, any system can process it within a seconds. But coming to the big data set, here is the difference. Spark will show the clear difference in a big data set. All right. So this is the concept of partition. All right. Okay, and what is a partition by? Partition by is again is a concept of, like, if you know Hive, then you know, right, there is a partitioning concept, bucketing concept. Similarly, partition by is a function here to partition the existing data set. All right, and why I shown here is the second application is because a cluster can execute, okay, multiple applications at a time. Okay, it is not a mandatory that whatever you submitted supposed to execute. No. So a cluster may execute multiple application, right? In multiple application, those applications will share the cluster resources and execute its task, right? That is the reason I showed you A1 is a different application, okay, which is executing an executor, let us say 2. Okay, that is the reason I just given a picture. So try to understand the concept. Okay, so we can execute multiple application at a time in a cluster if there are any if there are sufficient resources in a real time. All right, in real time it looks like this. Okay, now what are the important okay, let me think it got stuck. So we just rewind. Okay, what is the summary of this picture? Okay, I just noted a few points, then I will try to show you quickly, and then we'll jump into next important topic, that is query sources repartition. All right, so guys, if you see, parsing data on a file system is a way to improve the performance of the query when dealing with a large data set. Okay, so see, if somebody is asking you what are the performance tuning that you did it in your project, then you can say this word. Okay, so when you do partition and partitionBy, then that is also one of the performance tuning technique. Okay, please try to note it down. And second point is Spark assign one task for each partition, and each worker threads can only process one task at a time. That's what we've seen, right? See here, this is the, let us say this is a one file which sent to executor and it got created. Okay, so one task got created and one task executed at a time, right? Okay, so let us assume this executor having only one task. Okay, or one container. But if we have 2 files to execute, what it happens? Second file will be in a queue, right? Once first file completes the execution, then only second file will be executed. But since we are seeing here 2 containers which are available, okay, so 2 tasks are executing parallelly. If you see this here in the second executor, one task is executing, but the second slot is which is still empty, right? There is no work for this slot, right? For this executor, right? So that's what we mentioned here. At a time, it executes only one task, right? Thus, too few partitions, the application won't utilize all the cores available in the cluster, and it can cause data skewing problem. Okay, data skewing problem we'll see practical in a next class. Okay, try to understand. That means skewing is nothing but when we do a partitioning, right? Okay, So it may not divide a data in a uniform manner. All right. Some partitions may have a more records, some partitions may have few records. Okay. That is the concept of data skewing. Okay. We'll see in a practical. Okay. In a next sessions. Right. So let us assume what will happen. If I divided this 400 MB into, okay, 40 MB files, then we will see 10 files. Okay. And what happens if I divide it into this 400 MB to 4 MB each, then we will see 100 files, right? If you send 100 files to only these 4 executors, then obviously rest of the files will be in queue, right? It will take a hell lot of time to complete the processing. That means too many partitions also create performance issues. So we have to be caution based on the data set or the size of the data set, and based on the availability of resources, we have to decide number of partitions. This is a very important point. Okay, that is what is the third point. Okay, and with too many, sorry, fourth point. So with too many partition, it will bring overhead for Spark to manage too many small tasks. That's what we discussed, right? Okay. Now PySpark partitionBy is a function of PySpark.sql.dataFrameWriter class, which is to partition the large data sets. All right, that's what we discussed just now. So the function is coming from this module. All right. Okay, guys. So hope you understood the partition concept, but I want to explain how the partitionBy works in practical in a next session. All right, you don't worry on it. Just try to understand what exactly will happening when we do partition in a Spark. That is the subject for this stream, right? And these are the theory points that you can go ahead. Okay. And coming to it is a very important question, guys. Try to understand where we have to use a repartition, where we have to use a coalesce. Okay. Okay, repartition is to increase and decrease the number of partitions. We can use a repartition. Okay, and coalesce to decrease the number of partitions, we can use coalesce. Then you may have a doubt, right? Like, if repartition is doing increase and decrease, why should we use coalesce? This is another question, right? So there is a small difference between these two. Okay, so we'll discuss that in a practical way. All right, so let me open my screen or lab. There I will show you in practical. All right, guys. So if you see the third line, repartition and coalesce are very expensive operations as they shuffle data across many partitions. Hence, try to minimize using these as much as possible. All right. So wherever it is really necessary, then only we have to go with this repartition and coalesce functions. All right, guys. Please bear with me. I think you may get some more noise from my end due to a small function is going here. So please bear with me. All right, guys. Can you quickly check? Are you listening heavy noise from my end? Other than my voice?
No.
Oh,
No,
good.
it's okay.
Good. Anyway, guys. It's proper. Yeah. So what we will do? I will open here. Okay. RDD. I have created one list. Yeah. I just created a list. Let me. I'm just going on mute. Try to just watch my screen. Okay, you will get a clarity, and I will explain one by one. I'm getting a lot of noise.
There is spelling mistake in parallelize.
Right, guys. So yeah, we create a. We'll see. Get. See, by default, we have two partitions, right? Okay, and how can we write this? Then RDT dot save as. User. Right. We saved it, right? See, we saved an RDD now, and if you go to HDFS path, then we will see two partitions by default. We haven't given any number of partitions over there, right? Right. So let me open here. Hadoop fs -ls. Okay. User sample. Okay. Okay. Let me create one more time. Not data save as text user. Where it is going? Oh, sorry. So it has created a multiple times. If you see under user, our file got created here. Both are created. Okay. So if you see, two part files got created, right? So by default, we haven't mentioned anything, but it got created a two part file, right? So what we will do now, we go here. Okay. Now we created RDD, right? So RDD1 equal to RDD dot repartition of, let us say, 4. Okay, created. Let it be here only. Output underscore part repart. What is this? This is the RDD1, right? So we did a repartitioning. Okay, we saved it. We'll go back and see here how many files got created. It should be 4, right? So since we did a repartition, so we will see here the same place, or in a, I think we given a other file, right? Like underscore repart. What is the, it is here. Okay, under narration. See, repart is created, right? You see output for repart. See here, we are able to see these many files. Okay, total these many files. We have only 6 minutes left. I don't know. We can able to complete it. Fs minus cat. We can see the data as well. Okay, each data as well. Wait, let me. Don't have any. Okay, this is the second partition. We have this much data, and the third partition. I mean, are there? No, it is created empty. Then fourth partition. So only in a second partition and fourth partition have a data. All right. So what is then coalesce? We'll create RDD2. Sorry. RDD2 equal to RDD dot yes. Okay, we can only reduce. Okay, so if even you give more, it will show, it won't throw any error, but when you go back to backend data set and see, then it won't increase the a number of partitions. Okay, if we have only two partitions, let me first of all do it. Yeah, earlier we had two partitions, right? Then we did a 4. Okay, then we will use we can use anyone. Let me, I just want to show more, but I don't know why it is created. I supposed to see the data actually. Okay, so to show you difference between coalesce and repartition, right? So we have to see data in all the partitions, then only we can able to understand better. So that is what my intention. Okay. Repartition, let me partition 1. So repartition 1. We have given only 3, right? So it will create only 3 partitions. We're not able to see data in a first partition. It is horrible. I think we need to take a lot of the huge data, then only it can able to do the repartition, because here if you see in a partition 1 we are unable to see the data. Okay, in a partition 1 and 2 only we have, and in a partition 0 if you see we don't have any data. But to show you difference between the coalesce and repartition, I want take more data, because since these are a very small data set, I am unable to show you. I think what I will do, I will take a big file and show you the clarity between this coalesce and repartition in the next class. Okay, I think I have only 2.5 minutes left now, so I am unable to show you now. But hope you understood the concept, like what I am exactly going to explain. So here in a coalesce, right? In a coalesce, you cannot increase the number of partitions which are having. Let us say we have two partitions here, right? We have two partitions here, correct? So if you see rdd dot get num partitions, we have two here, right? So either we can make it 1 or leave it like 2, but we cannot increase to 4 or 3 by using coalesce. So it won't throw any error. Okay, even if you use a coalesce, it won't throw any error. If you see it won't throw any error now, right? So let me save also. Okay, see here, but it won't throw any error. Okay, I will go to here. Let me go here and check it. All right, cool. If you see, we're supposed to see 3, right? What is that name which we given? Okay, cool. But it haven't changed anything. Okay, it doesn't change anything, right? Let us say we can do coalesce 1. Okay, let me save call 1 and go here, call 1. You can see only one partition. See here, we can able to reduce, but we cannot increase by using coalesce, right? Repartition, we can increase or decrease.